Now, in our last video, we concluded on how we can the principles necessary to convert from Cartesian form to polar form. And we have 4 questions to convert to polar form. So let's start from the first. 2 plus 4i. Now, the first thing to always do is to draw the Argand diagram. Drawing the Argand diagram, you will know the location. You will know the location of the complex number, whether it's in the first quadrant, second, third, or fourth quadrant. So drawing the Argand diagram, you can have 1, 2, 3, 4. 1, 2, 3, 4. And then we know that it is 2 real. Okay, this is the real part and this is the imaginary part. We are concerned with the positive real axis and the positive imaginary axis. So, and 4i. Okay, so the complex number, it's directed like this. So in essence, we can bring out this triangle, this. Therefore, let's draw the triangle out. As this being at an angle 90 degrees. The distance from here to here is 2, and the distance from here is 4. So we have this to be 2, we have this to be 4, and obviously our angle theta is arc in the modulus. So the first thing being easy to calculate is our angle, our modulus arc, which is equal to the square root of a squared plus b squared, right? And we know that this is our b. Okay, anyone? This is our b, and this is our a. Okay, because we are writing in the format of a plus bi. So this will give us 2 squared plus 4 squared, and this will give us 4 plus 16, and that will give us root 20. Now, next thing to calculate is our theta. What is our angle theta? Okay, now our angle theta will be arctan b over a. But to be sure, we know that the theta is facing, the side facing angle theta is the opposite, and the other side is the adjacent. Okay, so tan theta is equals to opposite over adjacent, right? And the opposite is 4 and the adjacent is 2. So tan theta is equals to 4 over 2, or we say tan theta is equals to 2, and theta is arctan 2, and arctan 2 in degrees is 63.43 degrees. Now, having that been established, we know that we are in the first quadrant, so our argument z is equals to theta. No argument about that. So, and we recall that in Cartesian form, our z is equals to a plus bi, and in polar form, our z is equals to r cos theta plus I sine theta. Now, a quick thing to note that whatever theta we are imputing now, okay, will be the argument of z, okay, because this system works only for the first quadrant where theta is equals to argument theta, but then we begin to advance. So let's impute it. So we have z is equals to r plus theta plus I sine theta. So z is equals to r is root 20, and cos theta, the argument that we are actually using, is 63.43 degrees plus I sine the theta again, 63.43 degrees, and this also can be written as root 20, 63.43 degrees. Remember, we established it here. It can be written in these two formats: r into cos theta plus I sin theta, and r with an angle showing conjoint of 63.43 degrees. Now, moving on, definitely this is our final answer. Okay, now let's pick the second question. Question 2. Minus 5 plus 2i. As usual, the first thing to do is to draw the argand diagram. Drawing the argand diagram, we realize that we have a negative real part and positive imaginary part. So this is minus 5 and this is 2i. Imaginary, negative real. Okay. Now this meets with this. We have this. So having that been established, we can draw out our triangle and we can repeat it here. And the distance from here to here is 2, the height is 2, and the base is 5, not negative 5, 5. So in essence, we can call this 5 and we can call this 2 with angle theta. So after that being done, we can calculate our r to be equal to the square root of a squared plus b squared. That will be r is equal to square root of minus 5 squared plus 2 squared. So r is equal to square root of 25 plus 4. So r is equal to square root of 29. The angle is facing which side? Angle theta is facing this side. Okay, so the 2 becomes the opposite and the 5 becomes the adjacent. So in essence, tan theta is equals to opposite over adjacent. The opposite is 2 and the adjacent is 5. So tan theta is equals to 2 over 5. So theta is arctan 2 over 5. So we can say that theta is arctan 2 over 5. So for 21.80 degrees. Now, which quadrant is this? Is in the second quadrant. Okay, and if it is in the second quadrant, we will notice that our argument z, okay, will be equals to 180 minus theta. Now let's confirm. Since the complex number is here in this format, okay, and we call this our theta, And since the argument actually starts counting from here, so we can call this argument Z. The angle or the straight line is 180 degrees. So argument Z plus theta is equals to 180 degrees. So argument Z is equals to 180 degrees minus theta. Now, in some textbook, okay, they might explain it that this is E. Okay, this is E and this is theta. Okay, and theta plus E is equal to 180 degrees, and theta will be equals to 180 degrees minus E. Right? So in that case, what we have here and what we have here will be similar. Okay, but not to confuse us because we have started with theta minus E, 180 minus theta. So now let's go straight to slot it into the polar form. Remember that Z is equals to R cos theta plus I sine theta. Now before that, this 2 theta here will be slotting. Okay, we change to argument Z. Okay, so therefore we are saying that Z is equals to R into cos, that's argument Z, to be maybe a bit complicated. So therefore we can say Z is equals to our R is root 29 cos. Remember that these 2 theta here are being slotted for actually the argument Z, which is 180 minus theta, and 180 minus theta, that's 180 minus 21.8 degrees, and 180 minus 21.8 degrees will give us 158, okay, 21.2 degrees. Okay, so this gives us 158.2 degrees plus I sine 158.2 degrees. Call that this theta, this 2 theta, 1 and 2 are being switched for the argument Z. Okay, so henceforth we can write it as root 29 158.2 degrees. Now this brings us to the end because this is the answer for question 2. Now moving on to question 3, which will have it to be minus 1 minus I. Okay, you can see here that this one has a negative real and a negative imaginary, negative real and a negative imaginary. So with respect to that, we can draw an Argand diagram for it, where after the negative imaginary and also the negative real. So this is minus 1 and this can become minus I, minus 1I as the case may be. So we draw our Argand diagram, okay, and the triangle it gives can be split out, and we know that the distance from here to here is 1 and the distance from here to here is also 1, not minus 1 please. So bringing out the right angled triangle, we know that this is 1, this is 1, and also this is argument theta. Oh, sorry, just theta. So therefore, can evaluate our R. And evaluating our R, we have R to be equal to the square root of A squared plus B squared. So r is equals to 1 squared plus 1 squared, which is equals to square root of 1 plus 1, and this will give us root 2. Now, having done that, the side facing the angle theta is known as the opposite, and the other side is known as the adjacent. So therefore, our tan theta, which is opposite over adjacent, is equals to 1 over 1, because the opposite is 1 and the adjacent is 1. So our tan theta is equals to 1 over 1 is 1. And our theta will be arctan 1. Now, and our arctan 1 is 45 degrees. Arctan 1 is 45 degrees. So therefore, we now remember that we are in the third quadrant. Okay, and this is the angle theta. Okay, and the argument E starts counting from the negative, from the positive x-axis. So this is our argument Z, which is equals to 180 degrees plus theta. 180 degrees plus theta. So after being that said, our Z is equals to R into cos theta plus I sin theta. Understanding that this 2 theta now becomes the argument Z. With respect to that, our Z is equals to R, and our R is root 2 cos theta, which is our theta, which is now argument Z, and since our argument Z is 180 plus theta, so we can come here and say argument Z is 180 plus 45 degrees. So 180 plus 45 degrees is 225 degrees. So this gives us cos 2 to 5 plus I sine 2 to 5 degrees. Now Z will be equal to root 2 with this in 2 to 5 degrees. Now this is the final answer. Now we are done with question 3. Moving on, let's solve for question 4. We will have 4 is equals to minus 3i. If 4 is equals to minus 3i, that means we have a positive real and a negative imaginary. So we draw the Argand diagram. The Argand diagram shows that we have positive real of 4 and negative imaginary of minus 3. So when come together, we have this, knowing that the distance between here and the positive real axis is 4, and the distance between the negative imaginary is 3. In that case, we can now bring out our triangle, right angle triangle. Okay, which is base being 4, this is 3, this is R, and we can call this our angle theta. Now we can now calculate our modulus as R, which is equal to the square root of a squared plus b squared. So our modulus R will be equal to 4 squared plus minus 3 squared, because a is equal to 4 and b is equal to minus 3. So our R will be equal to 16 plus 9, which is equal to root 25, and R is equal to 5. Now with that done, We can now evaluate our tan theta. Tan theta is opposite over adjacent. Okay. Now, what side is facing the angle theta? This is the opposite here. Is facing angle theta. So the 4 is the opposite and the 3 is the adjacent. So in that case, our tan theta is equals to opposite of 4 and adjacent of 3. Okay. So our tan theta, or go straight to theta, is equals to arctan 4 over 3. And arctan 4 over 3 will be equal to 53.13 degrees. Now, with that done, we go back to our argand diagram. Okay, we know that this is Z, the complex number itself Z, and this is our angle theta. And the complex number, the argand when Z is being read or measured from the positive x-axis. So it is come from here to here. Okay, and because of that, we know that our argument Z is 360 degrees minus theta. Okay, so after that is done, we know that our argument Z is 360 degree minus 53.13 degrees, which will be equal to 306.87 degrees. Now, recall that in polar form, our Z is equal to the R cos theta plus I sin theta, where the two theta are now argument Z. Okay, so our R, which is 5, comma theta, which is now argument Z, which is 306.87 degrees, plus I sine 306.87 degrees. Okay, and this can be further written as 5 argument 306.87 degrees. So questions can come in any form. In this format, this can be A plus BI minus A plus BI minus A minus BI, A minus BI. I know that here theta or argument Z is equals to theta. Here argument Z is equals to 180 minus theta. Argument Z is equals to 180 plus theta. And here argument Z is equal to 360 minus theta. So our understanding of this chart will make a conversion from Cartesian form to polar form far and way easier. Now, given we have a polar form, now let's convert from polar to Cartesian. Okay, now it is quite easy. Say for instance, we are given a question of Z is equals to 5. We can say 5.385 argument 158 degrees. Now in this case, all we just have to do is to recall that Z is equals to R into cos theta plus I sin theta. Okay, so z will now be equals to, this is our arc and this will be our theta, 5.385 into cos 158 degrees plus I sine 158 degrees. So when we open the brackets, we can say that this is 5.385 into cos 158 degrees, which is minus 0.9272 plus I into sine 158, which is 0.37646. Now this will give us 5.385 into minus 0.9272 plus 0.37465. Now we now open the brackets. Now we see that we have 5.385 multiplied by minus 0.9272, which will give us minus 4.9929 plus 5.385 multiplied by 0.3746, which will give us 2.0172I. Now we might be asked to convert from polar to Cartesian format, and we can see that multiplication, or sorry, addition and subtraction is not possible. Addition and subtraction is not possible in polar form. Okay, to add or subtract in polar form, we have to first convert to Cartesian form, and from there we make our addition and subtraction and then convert back into polar form. We shall be looking at an example of that in the next video.